Right there.
What's the law of that?
Hold on. Alright, personality psychologist. What do you think personality psychologists do? Yeah, they're the people that help create the personality test. They're those people that help create like the traits. They're the type of people that would do that. They're the ones that maybe help design it. So she was asking about the subfields in psychology, which we left off on last time. Okay, and she wanted to know a little bit about. Carissa said basically it's self-explanatory in terms of if they start talking about what could be a self-explanatory. Making people healthier, that's going to be a health psychologist. Right? So just kind of make sure you know what the term stands for. So like forensic is the only one that is something that you maybe haven't seen in a while. So forensic psychologist is going to be the ones that work with the law. Okay? We left off with naming the 5 theories, or naming the 5 methods in research. Okay, so we named, and this is if you guys look at the research packet or the little packet number 1. Okay, are there any questions in terms of any of the methods? This is where I had you guys write down the different methods yesterday. And when you went through, for survey, you need to know wording effects, random sampling, false consensus. I think it's on there. You've never seen that word before. False consensus is that you get data back and it doesn't describe the study. So if you see that on there and you're not sure what that means. Okay. What's naturalistic observation and what was the Hawthorne effect? Yeah.
Isn't that when people just go in and actually observe, like an administrator would come here, they would just observe you teaching him, and the Hawthorne effect is that I think that guy he performed an experiment to see something to do with lighting and would improve productivity in a factory or something like that. And what happened was that people will improve their performance when they're being observed, as when they couldn't really tell if it was the lighting at all or if it was just the fact that they were being watched.
Yeah, so in the 1950s, there was a study that was being done where they wanted to see if the lighting impacts productivity. So all these researchers came into the factory, and all of a sudden everybody started working better. Okay, and then the researchers left, and they noticed that all of a sudden there was a decline in productivity. And so what they did was they brought the researchers back, and guess what happened? Everybody started doing stuff again. So that's just an example of naturalistic observation. You should know the Hawthorne effect. Okay. Correlation, you're showing a relationship between 2 things. It does not, it shows a prediction. It does not prove cause. Okay. And then the things that you need to know for when you're looking at correlation, somebody on the top of your sheet here, write down an example of a positive correlation, write down an example of a negative correlation for me. How would you know the difference between a positive and a negative? So this is like history and research. This is the one that they're just jot down maybe a positive and a negative to know an example of one. Alright, so what's an example of one, Puppy? Either one.
Positive is you eat more, you gain more weight, so both of them are rising.
Okay, you eat less, you gain less weight. That's both positive. Both going up, both going down. Okay, what can be a negative correlation? Yeah, Mira?
The more you smoke, the less you feel tired. I don't know.
The worse your health is.
Yeah. The more you smoke, the worse your health is. Very, very good. Okay, or the shorter the lifespan. Sure. Okay, so those are 2 good examples of positive and negative correlation. Don't forget for the correlation coefficient, the closer it is to 1, the stronger the correlation. So Carolina, okay, is 0.7, 0.78, or negative 0.89 stronger? Which one's a stronger correlation? Yeah, negative 0.89, because it's closer to 1. I don't know how many times people were getting it wrong. It doesn't matter if it's 1 or negative 1, whichever one is closer. Okay, so another example could be 0.5 and 0.8. Which one is a stronger correlation? 0.8. Okay, whichever one is closer to 1. I think they did some examples on there where they were throwing you for loops. Which one's closer to 1? Negative 0.2. Okay, negative 0.2. In terms of this one's closer to 1 versus this one. Okay, it doesn't matter if it's positive or negative. So it's going to say which one has a stronger correlation coefficient. That's a question that a lot of you guys were tripping up on. Okay. Other stuff in experiment, okay, you need to know double-blind experiment. I'm looking under experimentation. It tries to prove cause and effect. You need to make sure you're following the procedures. You have blind study. What's a blind study before we jump into double blind? Yeah, one person doesn't know that they're getting experiments on. In double blind, the experimenter and the people that they're experimenting on, they don't know who's getting the actual effects. Okay, so they might set up the experiment for me, and I'm going to be the one administering the drug. I don't know if this is the drug or if this is just a bottle of pop. I don't know which one is going to be the one that they're distributing to. So there's no effects because of the experiment. Alright? Hopefully you know the experimental and control. Experimental are the ones that are obviously getting manipulated. Control stays the same. Independent and dependent variables, we had a lot of examples on that one, and we're going to probably go over some in class. What are confounding variables? Yeah, other variables that are in the experiment that skew the data. So if I said that I want to know the effects of music on their memory, okay, what can other things that can impact somebody's data?
There's time of day that they're memorizing.
Time of day that they're memorizing. Who you're actually evaluating. Does that make sense? Do you want me to go over an example with that, or are you guys good? You're good? Okay. And then random selection and random assignment, those are both two things. The big one is random assignment. You're randomly selecting or assigning people to different parties. Okay, I'm going to wait on statistics because that's my big chunk we want me to go over in class. All right, anything else on this before we jump into neuroscience? You guys good? All right, let's take a look at the neuroscience perspective. All right, go to page 2. And under part 3, can you draw and draw the branches of the nervous system? Okay. In terms of, I already left you out there. I put central on there. And the top portion is probably the nervous system. But if you have to do the breakdown of the nervous system, how would you break it down? You know how to do that. Let's give it down part 3. All right, Peter, go.
Okay, nervous system, and then central, and peripheral, automatic, and somatic, parasympathetic, under somatic,
Which one is the parasympathetic, sympathetic, autonomic? Autonomic. You got it. It's okay, Peter. It's over here. Okay, so you're going to have parasympathetic and sympathetic nervous system. Okay, that branch off of this. Okay, what branches off the central? Brain, spinal cord. Good. know the difference between sympathetic and parasympathetic? Okay, so what's something that your body's gonna do with sympathetic? Arouse. So this is gonna be otherwise known as fight/flight. Meaning that you're going to fight and then flee. Or you're gonna fight or flee when you're in danger. So it's gonna speed you up, it's gonna keep you alive. Versus parasympathetic, rest and digest. There was a question on the test that everybody kept messing up because they thought that your body digested during sympathetic nervous system because you think that your body speeds up and digests food. It's actually conserving energy and doing anything it can to keep you alive. So it's not going to worry about going to the bathroom when it's trying to keep you alive. It's going to conserve that energy and use it at other times. Okay. What about if we had, so a big part of this section is the nervous system. I think a lot of us forget that the nervous system is a big part of the brain unit. The other stuff under the nervous system that you need to know is the neurons. So look at the top portion of the chart there. Okay, if you had to tell me what the axons, dendrites, myelin sheath, cell body does, can you just jot down a word that helps you remember this term? So the axons help send the messages. What does the dendrites do? What does the myelin sheath? What is the cell body? Right, what does the dendrites do? Receive messages. Okay, so the axons send, dendrites receive, however you're remembering that tool. The myelin sheath. What's the myelin sheath? Protects, speeds up, and which disorders should you think about when you think about myelin sheath? MS, multiple sclerosis. Okay, so that's another disease that you should be able to pin. Cell body, okay, just keeps the, I would say, the neuron healthy. Okay, then you have 2 or 3 different types of neurons. Can you remember the 3 different types? And, okay, see if you can figure out where they're found. Are they found in the central or are they found in the peripheral? So one is inner. Where would you put them? Alright, what are the 3 different types? Jennifer? Inner? River? Motor? Sensory? Sensory. Okay. Which ones are in the central nervous system?
Inner.
Yeah, inner. Okay, are in the central nervous system. Which ones are the peripheral? Motor and sensory. Okay. These are technically the nerves. The peripheral nervous system is like the nerve highway of your body. So these are sending messages to and from the brain. Okay, and then you have the motor neurons. Motor neurons are going to take information away from the brain. And remember, sensory information take info to the brain. Oh my gosh, I just touched that with a hot pan and take those neurons to the brain. And then what's going to happen is information is going to go back to your hand, your motor neurons, and pull it away. Okay? So if you look at the front page of your little packet here, neural communication, we haven't gotten into yet. Okay, but if you take a look halfway, where's that? I think it's on here. Oh, if you take a look at the number 2, organizational of the nervous system, you have a nice little breakdown that you guys just drew out: central nervous system versus peripheral nervous system, somatic versus autonomic, sympathetic versus parasympathetic. And then I drew on there for you where the motor neurons and sensory neurons coming from, and then where the inner neurons are coming from. So if you could do that nice little nervous system by yourself, for number 2, you should be pretty confident in the different order, and I would say the breakdowns of the neurons. Okay. Jumping down to number 3, why is the endocrine important? The endocrine system is important because it's the connection between your growth system and your brain. Remember, what types of, instead of neurons, what runs in the endocrine system? Hormones. Which one sends information faster? Neurons. Neurons move faster because this is moving by blood. Okay? The ones that help make the neurons for that are the pituitary gland. So the pituitary gland is the link between the endocrine system and the nervous system, if you remember that. Okay? The adrenal glands are also a part of the endocrine system, and they help with create the stress hormones. Okay? And the stress hormones that I'm going to show you guys in a minute are epinephrine, that helps you deal with stress. Okay? So a big part of it that you have to know, here's the big part of the nervous system. You got to know the neurons. You guys just talked about the different types of neurons. And then the other big part of the nervous system is the different neurotransmitters. So if you go to page 5, I gave you a nice breakdown of the different neurotransmitters here. First one is acetylcholine. Okay, it deals with memory. I would know, maybe not so much the location, but I would really know the neurotransmitter, the function, what it helps with, and then the associated disease. Okay, so you have to know like the drug. I maybe not spend so much time on that. We haven't really talked about that a lot. Okay, but I would definitely know acetylcholine deals with memory, deals with Alzheimer's. Remember A, that's how I remember it. Okay, dopamine, we've been talking about it in some of your classes. Dopamine helps if you have an excess amount, a surplus, it's going to give you schizophrenia. And if you haven't talked about schizophrenia in my class, then you may not know that or remember that. Okay, and it also helps with movement, attention, motion, motor activity, motivation. Okay, if anything, though, it's linked to schizophrenia. Okay, a lack of it may help with depression. It might also help with Parkinson's disease. And serotonin, you should know this one specifically, okay, with depression. There's a lot of other ones on there, but I would just know, as long as you know serotonin, depression, you'll be good. Okay, epinephrine here, and I think that this is what a lot of students were confused on before, helps with the fight or flight. So it's released to give you energy, epinephrine. And then norepinephrine, okay, it also helps with fight or flight, but it also helps in terms of other things such as if you have a deficient amount, it can lead to depression. Okay, endorphins, they help with the natural high. We talked about endorphins in the sensation unit. GABA helps with sleep, and it also can result in panic attacks. The big one for that is sleep. And the last one is glutamate, which can give you migraines. My mate gives me migraines. Okay, so this might help you a little bit in terms of organizing the neurotransmitters. Some of it is just way too much overload, but I would kind of recap what I just said in terms of the function and then the associated disease that might help you. Okay, if you go back to page 4, here's another, if you look under neurotransmitters, here's another little, I would say, shorter version of the neurotransmitters, 1 through 5. See if you could take a minute, and it helps with muscle movement, and it helps with memory, and if you lack it, it leads to Alzheimer's. See if you remember what that one might be. This is an easier chart to know. gonna try the first one. We're gonna name it acetylcholine. Right? Second one helps with your mood. Serotonin. Helps with eating and sleeping. This one, it might help too if I say this. Helps with sleeping, GABA. So maybe add that to the little list right there. Besides anti-anxiety drugs, it helps with sleep. Next one acts as morphine. Endorphins, a natural painkiller. And then this one leads to Parkinson's and schizophrenia. Dopamine. So yeah, it doesn't have all of them on there, but this might be a nice shorter list where you got all the neurotransmitters that can help you remember them. Okay. So you got your big things that you need to pull on this unit. Yeah, I know I know that you really are worried about firing the neurons and all that kind of stuff, but let's just get down to basic details right now. Like, let's just go home and review, like, make sure you know those neurons, parts of the neuron. Make sure you know the different types and where you're found. Make sure you can describe the nervous system, and make sure you're going through and memorizing those neurotransmitters. That's the biggest thing that you need to know from this section. Okay, so if you kind of take a look at the front overview, it talks about, I think, number 2 is a big one. Like, hammer that out, memorize that. Okay, know the difference between sympathetic and parasympathetic. I can almost guarantee there's going to be a question on that. And number 3, know the purpose of the endocrine system. Okay, and then I know that didn't have too much, the neurotransmitters were at the bottom of the box, number 1. And you can kind of take a look at in terms of acetylcholine, there's another little overview there. Yeah, we didn't get into reuptake and polarization, but let's not forget about that yet. There may be, like I said, one question on the reuptake. Okay, you confident to move on to the brain? Any questions on the nervous system or neurotransmitters? Did that help at all? Kind of reviewing it a little bit? Okay. Take a look at the brain, part 4. See if you can jot down at least the part of the cortex. Maybe you know some of the areas of the limbic system, and maybe you know some of the areas of the hindbrain. Those are how I broke apart the brain. So when we study them. So take a little, I think question number 4, right? Here. Go to page 3. That's good. Page 3 says can you jot down the areas of the brain? First one was the hindbrain. All right, ready? Stand up. I'll help you a little bit. Ready? Okay, brain stem. I'm the oldest. Okay, medulla. Stay in the reticular formation. Stiffs your sensory information, keeps you alert. Pons. Helps you sleep. Cerebellum. Helps you balance. Okay, so you got brain stem. Medulla. Pons. Reticular formation. And cerebellum. All that stuff is part of the what? Hindbrain. Jot it down. Okay, you got brain stem. We start first. All the innermost function, all of these you need to survive. So you got brain stem. Hindbrain. You got brain stem. I'm the oldest. Medulla. What's that do? Heart and breathing. Okay, you got reticular formation. Keeps you alert. You got cerebellum. Balance, coordination. And then you got reticular formation. Keeps you alert. Yep, okay. Thank you. Okay? All of them are part of the hindbrain. Hindbrain you need for survival. You cannot live without this. It's the innermost core. All species have a hindbrain. And if they're talking about a question on evolution or evolutionary, this is the one that was born, or this is the one that, all animals or species has. As we expand out of the brain, okay, other animals don't have cortex. That's like higher level thinking. Okay? All right, let's talk a little bit about the limbic system. Stand up. Okay, pituitary gland. It now helps with growth, right? Thalamus. No, everything but smell. Sensory switchboard. You got hypothalamus. Eating, drinking. Remember, you have the lateral hypothalamus, central medial hypothalamus. Okay, then you have the. Oh my God. Okay, what? Hippocampus. So appropriate. Oh my God, I forgot, right? And then you have the corpus callosum, which connects the two different hemispheres. Right? So you got pituitary, thalamus, hypothalamus, hippocampus, corpus callosum, thalamus, hypothalamus, pituitary gland, and let's say hippocampus. All right, so jot those down. Those are all the limbic system. Okay, so those what make life really good. Okay, you need your memory. You need to eat, drink, and think. If you want to talk about the hypothalamus, that also is dealing with sex. Okay, the other one deals with growth. You don't want to be walking around as a 5'2" person like myself. You want to make sure you're actually growing. I don't know. Hey, I know. It's okay. Sure. Second one. Okay. Second one here. Okay. So the first one was hippocampus, memory, thalamus, sensory switchboard there, folks. Hypothalamus, eating, drinking, sexual functioning, sexual motivation. Remember the motivation unit. Pituitary gland, growth, and you have corpus callosum. That connects the two hemispheres. Literally, the student said that they were doing the dance in the chair when they were taking the test. It supposedly helps. But you need to think about those movements. Think about those movements. All right, what's the last one? Cortex, right? So you can stand up. That's cortex. Cortex. Frontal lobe. Phineas Gage, that guy was hit here. What changed his personality and logic? All right? You have parietal. The sense of touch. It helps with touch. Then you have temporal, hearing, and it also deals with memory, if you remember. And then the last one, occipital. You can say it's a back because that's where they're located. Last year they had a picture of the brain on it. Only picture they've had in a long time, and it had them identify the occipital. Occipital is not in the front. Occipital is in the back. Okay? You guys can jot down, jot them up. Remember FPOP. Okay, I know that's Ms. Dubkowski's acronym to help her remember them. Frontal, parietal, occipital, temporal. That might help you remember it. Okay. They drew the brain last year. It looks something like this. Okay, you had to draw the brain on like map of Alzheimer's. Okay, and so identify A, B, C, D. Which one is the occipital? D. Know that this is the back. Okay, this is by the a lot of the times it's by the brain sense, maybe right here. Connect or not. Okay, which one's the frontal? A. Which one's the parietal? C. Okay, and then which one's the temporal? C. I've never seen them ask any other structure of the brain besides this cortex. So if you're going to know anything, then know that at least you'd be able to identify that. Okay? Alright, if we had to talk about other things that the frontal does, know that it deals with personality, logic, reasoning, parietal deal with touch. Okay, you got sight, back, occipital, then you have temporal, hearing, and memory. Couple of things you need to know. Broca and the larynx. Both of them are in the what hemisphere? Left. Okay. One of them, I want to make sure. Yeah, broken speech, and it's in the left frontal. Left frontal. Larynx, comprehension, and it's in the left temporal. Comprehension would be that they can still talk, but they don't understand what you're talking about, or you are not making sense when you're talking. The football went to the band camp, and I'm going to go for a dinner this evening. What? She can still talk, she just doesn't comprehend. And you should know that, we're going to talk a little bit, but Paul Broca was the person that came up with that one. We'll talk about those people in a minute. Okay? So big thing, you've got to know the parts. If you go to the front page and you go under number 3, okay, I've labeled them all for you. Okay, so that's kind of the exercise we just did. So make sure you can identify plasticity is where the brain can grow back. Okay, that's all that word is. It's the ability to be grown back. And we saw the little girl that had half of her brain removed and she was able to survive because of brain plasticity. Then you got the hindbrain there, the cerebellum, the medulla, the pons, the reticular formation. You have the forebrain or the limbic system, thalamus, hippocampus, and amygdala, hypothalamus. And then you have the cerebrum, the cerebral cortex, the prefrontal cortex, okay, which is a lot of planning, and then the frontal. You guys kind of learned it together. Parietal, temporal, and occipital. Okay, so again, that's just another thing that you can go home this weekend and just like embed this stuff in your head. Yeah.
What's the somatosensory cortex?
Somatosensory, remember that's also under the parietal and has to deal with feeling. Angular gyrus is not, don't worry about that, it's not on the top. The angular gyrus is like a part of the cortex.
What about association areas?
Where are those at?
Everywhere?
Everywhere. And they help with what? Association areas are the areas in the brain that help with understanding, reasoning, and logic. Okay, so you should know that they're the part of the brain. Each of the cortex has an association area. Okay, so the frontals have to deal with like logic, reasoning, but it also has to deal with personality. So a lot of the times they have an association area, and they have an area that deals with some sort of sensory thing. Frontal just basically deals with your personality. Parietal deals with touch, but it also deals with math. So that's the association area. Sight, okay, you got sight as your sense, but the occipital lobe also deals with logic. Okay, hearing, that's the sense, and then the association area is memory. Does that make sense? One deals with the sense, and then one deals with the higher level thinking. Whew. I'm really digging back on my hippocampus right now. What's the difference between the left and right hemisphere?
The right is more creative.
Right's creative,
Left is logic.
left is logical. So you should know the difference between left and right. Those are the two hemispheres. Okay, go on to part 3. There's people there. Okay, you should probably know these people that have to deal with the brain. Paul Broca, what did he help develop? The Broca area, right? That's pretty common sense. Broca area deals with speech. Phineas Gage, personality. Yeah, frontal lobe. He was the guy that had the accident with the frontal lobe. Charles Darwin, they talked about him in this one. Genetic, evolutionary. my gosh, you're gonna have to help me with Michael Gunzinga, I can't remember this one. Robert Sperry, I know, was the person that did the split brain. Remember when he cut the brain? And Carl Wernicke, that makes sense, it's what? The Wernicke area, yeah. Using my cheat sheet. Yeah.
Are the split brain and the hemispherectomy like the same? Or is it?
Hemispherectomy is where they take half of your hemisphere out and they see whether or not you can survive with one hemisphere. And then the split brain is where they cut the corpus callosum to see if there's a communication. Michael Gunzinga was the other guy that was in the video with the split brain procedure. Do you remember he was having them draw the different elements? And he said, I'm going to see if they can draw a tree stump. And then he was having the guy draw a tree stump. He's another one with split brain. Okay? Questions here? Go to page 4. First part, 1 through 6, see if you could identify the part of the cortex. Decision making contains the broca area and motor cortex. Good? First one,
Frontal.
frontal, right? Decision making is broca. Second one, Peter?
Parietal.
Good. Third one?
Temporal.
Good. Last one?
Occipital.
Good. Keep going.
Left hemisphere.
Yep.
Right
And?
hemisphere.
And right. Left and right. Okay? You have a nice little neurons there. You have your neural communication, which I didn't spend a ton of time on today. Okay, and then if you want to take a look at the brain scans. Ooh, go over the brain scans. First one, brain activities during sleep, is the EEG, right? See if you can identify 2, 3, and 4 there. Those are the ones you guys always ask me. Look at different scans. Your choices are fMRI, MRI, and then PET scan. Probably figured out by the way that the terminology is that they're using that. Magnetic is going to be what? Using the magnetic force. MRI. Also brain tissue. They use a lot of radio waves and radioactivity to take the pictures. The magnetic force, MRI. And they look at your brain tissue. Okay, so radio waves and magnetic images to see the structure. The third one is brain functioning to see blood flow. fMRI. Okay, so the show, the little video I showed you today of the schizophrenia with the pink color, that was an fMRI, looking at the blood flow on the cortex. Okay. And then the last one scans for glucose. That's a PET scan. Remember I always remember that PET was eating glucose. Okay? Other questions on this? What's the difference between an agonist and an antagonist? So if you look on page 4.
Antagonist blocks the
So which one mimics?
agonist.
Agonist. So number 1 is the agonist, number 2 is the antagonist. Okay? Agonist. Yep. Not real good. Actually, yes, in the reference.
Change the one part as you get to.
Yeah, neurogen. Okay, so the rest of the stuff on there, page 4 is the neurotransmitters. I have a nice little summary there on page 6 and 7. Okay, and then there's some practice test questions. Okay. Any other questions on the brain? Go home, absorb that. I didn't want to throw them to the exhibitory all or none response at you yet, because I feel like you need to absorb that a little bit. Okay? Was that good? A little rusty for me on the brain, but on a what? I mean, you guys can stay here. Like Wednesday, Thursday. Yeah, I'm not really worried about it. Because I'd rather have you guys